We are doing homework number 8, problem number 1. That is the problem right there. It's just some scratch work. X is uniform from -2 to 2, with y equals a little g of little g of big X, with g of x equaling to 1 from -infinity to -1. 1 minus x from -1 to 0. -1 plus 2x from 0 to 1, and -1 from 1 to infinity. Okay, so here is my work for the first part, A. So this is my f of y. I'm gonna explain how I got that. So I drew out the g of x first, with everything I said before. There are two impulses at 1 and -1. Okay, so to find the area of those impulses, I look to see where it corresponds to on the f of x graph I have here, which is uniform from -2 to 2 with a height of 1/4, because 1/4 times 4 is 1. Okay, so there's my impulse at -1. Okay, so I'm looking at where y equals to -1. It's right here. And that corresponds to the area from 1 to 2 on the f of x graph, and the area of that is 1/4, so that is a area value of 1/4. Similarly, so I'm looking at when y equals to 1, y equals to 1 is right here, and that corresponds to the area when f of x equals to the range from -1 or -2 to -1, and that also equals 1/4. So there you go. There is the impulse value. And then everything in between, you need to use the fundamental theorem to find that. You have your f of x over your absolute value of g prime of x. Your f of x is 1/4, no matter what. And to find your g prime of x, you go back to the original problem. Right here, the slope is -1. Right here, the slope is 2. So there you go. So your g of x is your g prime of x is the slope of those lines at those intervals. So I found 2 and 1. -1, absolute value of that is 1. And so from -1 to 1, the slope is 1/8. The value is 1/8 for little f of y. And the value is 1/4 for little f of y from the interval of 1 to 2. Okay, I did a little summing up here. Little f of y equals to 1/8 from -1 to 1, 1/4 from 1 to 2, 1/4 times the delta value of y plus 1 at -1, and 1/4 times the delta value of y minus 1 at 1. Okay, so sorry, this is 1/4 times the delta value of y plus 1 at -1. I'm sorry if I misspoke that before. Okay, so going on to the big f of y graph. I was going to superimpose this on so you can see how I got my solution. Okay, so at -1, you have a jump to 1/4, right? Okay, that's good. Over here, you have a line with a slope of 1/8. And I did a little bit of y equals to mx plus b over here with, instead, it was big F of y equals to 1/8 y plus b. I want to find the b value, which is the y-intercept. I found that it was 3/8. So there's my y-intercept, and I also wanted to find what big F of y was when y equals to 1, and I found that it was, in fact, 1/2. So 1/8 times when y equals to 1, 1/8 times 1 is 1/8, plus 3/8 is 4/8, which equals 1/2. So I know when y equals to 1, big F of y equals to 1/2. So there's my point right there. At 1, there's another jump. Correspond that back over here. Jump that 1/4, and then you want to find the slope of this line, where the slope of that line is equal to 1/4 because of this little f of y value right here. So you try to find big F of y equals to 1/4 y plus b, with b equaling to 1/2. And I wanted to find what big F of y was at 2. So I plugged in y equals to 2. 2 times 1/4 is 1/2. 1/2 plus 1/2 is 1. So therefore, when y equals to 2, big F of y equals to 1. So you have 2 points, connect them. And then it flattens out at 1 when 2 equals, or when y is greater than 2. And then here's a little sum up. 0 when y is less than -1. 1 when y is greater than or equal to 2. And then everything in between are my equations of the lines between -1 and 1. The big F of y equals to 1/8 y plus 3/8. And between 1 and 2, big F of y equals to 1/4 y plus 1/2. Okay, and then now is where I want to show you how to find the expected value. So I'm going to do this on the paper. So you subtract this area A minus this area B. Okay, how I found this area, you just kind of like divvy it up into triangles and squares. Over here you have a jump of 1/4. 1/4 times 1 divided by 2 is 1/8. This is 1/4 times 1 is just 1/4. This is 1/4 times 1 is just 1/4. And this is actually 1/8 times 1 divided by 2 is 1/16. That ends up equaling to 1/4 plus 1/8 plus 1/4 plus 1/16. So you're going to subtract this area by this area. This equals to 1/4 times 1 is 1/4 plus this is 1/8, don't forget, because this is 3/8. 1/8 times 1 divided by 2 is 1/16. Common denominator it. Same thing over here. 1/4 turns into 4/16. 1/8 turns into 2/16. 1/4 turns into 4/16. You get 4 plus 2 plus 4 is 10. Plus 1 is 11/16 minus 5/16, which equals to 6/16, which equals to 3/8. So my expected value, I'm gonna write over here, is 3/8. However, you can also do it via formula, which is over here. Expected value of y equals to, from -infinity to infinity, y times f of y dy. Remember, your f of y is right here. So you use all these values. So you're basically just finding the area of this. So you do -1 to 2 because you're really only working from -1 to 2. Y times a quantity of 1/4 delta y plus 1 plus 1/4 delta y minus 1 plus 1/8 plus 1/4. And that also gives you 3/8. And that's it. Thanks for listening.